Hi, welcome to Genesis Engineers Academy. In this video, I am going to discuss on keys used in shaft and couplings. A key is a piece of steel inserted between the shaft and hub or boss of the pulley to connect these together in order to prevent a relative motion between them. So, the main aim of key is to assemble separately both coupling and shaft. So, it acts as an agent to transmit the torque from the shaft to the coupling and then another shaft. That is the situation. So, you can also guess like that one. Next one, this is the shaft and this is the keyway in shaft. So this is the key. Okay, so it is inserted, key is inserted in the keyway. Half of the keyway is in the shaft, the other half is in the what you call hub or boss. Next, it is always inserted parallel to the axis of the shaft. So the lower part of the key is always parallel, but the upper part sometimes will have the taper, that is 1:100. Okay, next one. The keys are used as temporary fastenings and are subjected to considerable crushing and shear stresses. So this means the key is subjected to both crushing or otherwise compress and also shear while transmitting the torque from the shaft to the coupling or hub of the boss of the pulley. Next, a keyway slot or recess in a shaft or hub of the pulley to accommodate a key. So it is a slot made by different operations, milling, shaping, and also sometimes you can make it on the lathe also. The functions of keys. So first it has to prevent the relative motion. That means shaft and the hub or coupling should move at the same velocity so that there won't be any difference in velocities. That is the relative motion of one piece, that is shaft and coupling, is 0. That means we can say that it is relative motion is 0. So the key prime aim is to prevent the relative motion, and also it has to transmit the torque from the shaft to the hub and from the hub to the another shaft. So these are the different types of keys. This is a rectangular keys. That means its cross section is rectangular. Next one is parallel keys. That means the upper one or bottom part will not have any taper. So this rectangular key may have the taper part over this one. That taper is 1:100. If that taper is not there, then we call it as a parallel key. And the other one is called square key. That is, it's in rectangular key, the cross section is rectangle. In square key, the cross section is square. And there is another called the end of this rectangular key or square key will have a facilitator, that is to remove this key from the hub and shaft. We provide this jib, so that is why it is called jib head keys. Jib head rectangular keys, jib head parallel keys, jib head square keys. All these things can be used as a jib. The difference only that is jib part. The next one is saddle key. So saddle means it rolls over the shaft and it can accommodate some types of misalignments. And the other one is called tangent keys. So these are tangent to the shaft. And the most important one is Woodruff key. Woodruff key is a part of a disc like. So if you cut any disc halfway, we can call that as a Woodruff key. So this accommodates according to the misalignment, so that there won't be misalignment. That facilitates the misalignment by adjusting itself. The next one is called feather key. So feather means it's just like so it is that is fitted in the keyway by using nut also sometimes. Next, the most important in gearbox in automobile, we use splined keys. So the key is integral part of the shaft. You understand that inserted key is also here. So this is the integral part. It is not a separate one, and it is will have the sliding facility. Splined key facility is it facilitates the sliding of this shaft. In this case, there is no sliding, right? This is about types of keys. For a subject one, classifications of keys. So classifications of keys. So keys, first one is a sunk key. That means it sinks into the keyway of the shaft and keyway of the hub or boss of the pulley, right? Next one is saddle key. Saddle means it is the one which is used in horse riding. Okay, so the rider will have a seat on the horse as a saddle. So it also, that is why it is called saddle key. And the third one is called tangent key. So this key acts at a tangent. It is assembled as a tangent to the shaft. And the third one, next one is round key. So it means a small rod is used, that we call it as a round. In that there is no much torque in this one. Next one is splined. So I have already told you the key is not a separate one. The key is a part of the shaft and the other part will have other keyway. In sunk key, we have separate keys, rectangular, just now we have discussed, and square, and as well parallel and jib head. All are same. By cross section wise, both are by looking same. Rectangular cross section, square cross section, it will have a taper 1:100. Okay. It will also have 1:100 and it will not have any taper, that is why it is called parallel. And to facilitate easy removal of the key, we provide jib at one end of the key. Next one is feather key, a small like sheet like. Okay. Next one is what is sunk key. So sunk keys are provided off in the keyway of the shaft, off in the keyway of the hub or boss of the pulley or gear. Okay, so you will be asked to have the proportions. Suppose D is the diameter of the shaft, then the key width will have D/4 and you can round it off, and the thickness of this D/6. Both width and thickness will have like this one. It's a rectangle, so this is D/4, this is D/6. So this is the key. And the upper part will have a taper. Okay, so that is 1:100, you can also say. Only the upper part, that is in the keyway of the hub or boss of the pulley or gear. So this is a key, this is a width, this is D/4, and this is thickness, this is d by 6. So we have to verify the stresses induced in the key, and then you can also go for sometimes square instead of rectangular. Next one is square key. Square key means d by 4 only. Width is d by 4 and thickness is also d by 4. So what would the item we have increased in square rectangular key? The thickness is d by 6, but in square key the thickness is d by 4, much higher that is. So it will have a very strong one. So majority of the larger shafts which transmit larger power, we use square key, right? Next, parallel key. What is the difference between parallel sunk key? Maybe rectangular or maybe square. Only difference is we don't have any taper on the top of the key. Next, jib head key. So it is a rectangular sunk key with a head at one end known as jib head. Got it? Next, it is usually provided to facilitate the removal of the key. So the usual proportions are rectangular proportions, so d by 4, thickness is d by 6, and the other, that is jib we use, the width is okay, say as that of this part, and the part is 1.5 times t, and this is a t, same thing, okay, and only here we have to provide a 45 degrees angle. This is a 45 degrees angle. If you draw like this one, so the height is 1.75, width is 1.5. From that you can make this jib. Okay, though it won't be go through into the that is a coupling part or above the any coupling or boss of this one. So next, feather key, a key attached to one member of the pair which permits relative axial movement of the other, known as feather key. What is the importance of this one? So this key is connected to only one, and by fixing this one you will have relative axial movement like this one. Okay, so like this one there is a free movement, but there is no rotational movement. So it is a special key of parallel type of which transmits turning moment and also permits axial movement. So in general there is only turning moment, there is no axial movement. So axial movement is possible only in feather key. It is fastened either to the shaft or hub, so the key being a sliding fit in the keyway of the moving place. If you are familiar with that limits and fits and all these things, so it is a sliding fit like a splined. Okay, next one is Woodruff key. So Woodruff key is adjusted like this one. Okay, so the Woodruff key is an easily adjustable key. It is a piece from a cylindrical disc, okay, having segmental cross section in front view. Okay, the key is generally used in machine tools and automobile construction. Okay, even if there is a misalignment, axial misalignment, lateral misalignment, angular misalignment, these three are misalignments. So it can accommodate all these things. Okay, so it accommodates itself to any taper in the hub or boss of the mating place. Okay, if there is any taper, it tilts, okay, by itself. Okay, if you encounters any taper here, it tilts. It won't be in a parallel position. Its extra depth in the shaft prevents any tendency to turn over in its keyway. So this is extra material that when it wants to turn, it won't have a turning movement. That is the importance of Woodruff key. Next one is design of a rectangular sunk key, also can be called as a square key also called as a jib, also sometimes. So first in key, what we usually do, we go for empirical formulas first. So based on empirical formula, you have to calculate what are the stresses induced. What are the stresses induced in the key? One is called torsional shear, the other one is compression or otherwise crushing stress. Okay, so this is the key width and thickness. So this half part is inserted in the shaft, half part will be in the hub. Got it? So key will be having this moment will provide one type of moment. This moment will provide another. What is this? This and this is one moment. What is this moment? It will have anti-clockwise, and this P1 will have clockwise, so that it balances. Now the force PP form a couple which tries to roll the key in the keyway, and the P1 form a resisting couple which prevents the roll the key in the keyway. So these couples will balance so that there will be no roll, that is rotation of the key in the keyway. If that happens, it won't transmit full torque or otherwise power. So it has to sit there only. Okay, next one. Considering the shearing strength of the key, the tangential shearing force acting at the circumference of the shaft. So this is this one. So this area is this is W and this is L. So the shearing area is L into W. Got my point? So this is shearing area. Shearing area into shearing stress will give us, I'll draw once again, tau L into W. So this forms shear force. Shear force, and this is the thing. Okay, this part I am taking, and if you take this is d by 2, that is radius. You got my point? So this shear force into, okay, this part is shear force into d by 2 will give us a torque. Okay, so from this you have to find out by giving the proportions, that is L is equal to 1.5D, okay, W is equal to D by 6, okay, and this is already there, this is shaft diameter by 6. Using these proportions, you have to calculate what is the stress induced and what are the permissible stresses. By comparing this one, you can also increase the dimensions of the key. See this, the torque transmitted by the shaft, okay, that is will be transmitted through key. So the same thing, this is shear stress, length of that one, width of that one, this is d by 2, this is a force, this is radius, that is called turning moment, also called as twisting moment. So this is the shear stress you have to calculate, and W is the width of the key, L is the length of the key. Now after having studied this one, we will move into the crushing of the key, that is a tangential crushing force acting at the circumference of this one. So this is the area, you understand? So this is already we know, this is thickness and this is W. Okay, next the shearing area or crushing area is, what is that? Crushing area is length into T by 2. So this height is T, it taking only half of this area is inserted in the key. So the key part, the that is the key part in the shaft will be subjected to crushing. That's why we take the L and the thickness that one. We don't consider that, but that is there in forming the couple also. Okay. For calculations, we use the part of the key in the key shaft. That has to be known to you. So this is crushing stress L. This is T by 2. This total part will give us area, and this is the stress. Stress into area will give us force. Force into d by 2, that is radius, will give us torque transmitted. Okay. By comparing these two, you have to fix the, that is it has to withstand both shear stress and also crushing stress. That's our design. Okay. So if the induced stress here is tau is less than the permissible shear stress or otherwise yield stress, you have to increase the size and then check whether it withstand the shear stress. Okay. So that's all for today. Subscribe if not subscribed.